this question asks us to calculate the ratio of acid to conjugate base for this particular reaction given its pKa value. To do that, we need to remember what a pKa value means. The pKa value is 20 for acetone. What that means is that the pKa equals the negative of the log of the Ka, which equals 20. We can solve for Ka. First, we'll move the negative sign over. The log of Ka is equal to negative 20, which means that Ka equals 10 to the negative 20th. If we know that Ka equals 10 to the negative 20th, Ka is the equilibrium constant for this reaction. And the equilibrium constant is equal to the concentration of the products over the concentration of the reagents. So that means it's the concentration of the acetate ion, or the acetone ion, times the concentration of H3O plus over the concentration of acetone. And all of that is equal to 10 to the negative 20. From here, we can pull out the ratio of acetone to the conjugate base as 10 to the negative 20, which we know is equal to 1 over 10 to the 20th, is equal to the ratio between acetone and its conjugate base. This means that the ratio of acetone to the conjugate base is 10 to the 20th to 1. This means that for every 1 molecule of the 1 molecule of acetone conjugate base, there are 10 to the 20th molecules of the acetone acid.